Good evening, students, class 12. Now we are going to start a new chapter, and that is chapter number 3, current electricity. Students, earlier we have studied the first unit, and all the first unit name was electrostatics, and it was based on that the charge is on rest. Whenever either we were studying Gauss theorem or we were studying Coulomb's law or we were studying any application of Gauss theorem, so everywhere we studied that the charge is totally on rest and charge wasn't moving. But now we are going to move the charge and we want to create the current. And that is known as current electricity. So that's gonna be a new segment for you, current electricity. Okay. So the very first definition you are going to begin with is electric current. So what is electric current? You already know. You have studied in class 10th. So the rate of flow of charge is known as electric current. That you know. But how to define this? Or what is the concept behind it? So let us understand it. Suppose we have a conductor, okay, and this can be in any shape. So I have taken in the shape of cuboid. Suppose we have a conductor, and what happens inside a conductor in the absence of electric field or in the absence of potential difference. So students, we already know inside a conductor there are number of free electrons. So free electrons, these free electrons are in random motion. So they are moving somewhere in such a way that they are cancelling out each other's effect. For example, suppose one electron is in this direction, another is in this direction, so net momentum is zero. Or we can say there is no net velocity in the absence of potential difference. Okay, we can understand this by the same example that suppose a number of people are standing, a group of number of people are standing somewhere, and none of them is moving in a particular direction. One is moving in this direction, another in this direction. So overall, where the crowd is moving currently, we will say there is no particular movement in any direction. So same is here, there is no movement of electron in any particular direction. So the net movement is zero. Now students, suppose I apply the potential difference. What is the meaning of potential difference? The meaning of potential difference is either we have applied a battery or a cell. So suppose we have applied a battery here. So between the plates of these battery, this terminal is offering a high potential and this terminal is offering a low potential. Suppose this is offering 10 volt, this plate is offering 5 volt. So what is the potential difference? Answer is 10 minus 5, 5 volt. So this is how potential difference has been created. Suppose V potential we have created here. Okay, so because of this V potential, this is positive terminal, so this terminal will become positive. This is negative terminal, so this terminal will become negative. Now students, from the high potential to the low potential, there is a direction of electric field. So electric field will be in this direction. Okay, and now electrons. The property of electron, that electron is always drifting in the opposite direction of field. What is the force applied on the electron? So already we have studied, suppose a Q charge is placed in the electric field. The force experienced by the charge is F is equal to Q. In the similar way, the electron will experience a force that is equal to F is equal to minus E. Now students, in which direction the electrons are supposed to move? So we already know that electrons move in the opposite direction of field. So electron will experience a force in this direction. So earlier, the condition of electron was that the electrons were moving in random motion and they were cancelling out each other's effect. Now, there will be a net movement in a particular direction. So the net movement will not be zero, or the electrons will gain a particular velocity in a particular direction. So electrons now will move in this direction like this. This electron will move in this direction and so on. Okay. Now students, as the electrons have gained the particular direction, so whenever there is a flow of charge, it originates the current. What will be the direction of current? So students, please remember the current always is in the opposite direction of the flow of electrons. So current direction will be from the high potential to the low potential. So this will be the direction of current. Now students, why we need the current? Because we want to calculate that what is overall rate of flow of charge. For example, suppose in time t, q coulomb of charge has been flown. Then in unit time, how much charge has been flown? That is q upon t. So the charge which will flow in a unit time will be known as current. So I is equal to q upon t. So this is how we can define electric current. The charge flows per unit time is known as current. Or we can say the rate of flow of charge with respect to time is known as electric current. Now students, the unit for electric current is ampere. You have to remember the unit for electric current, that is ampere. Okay, how to define 1 ampere? So students, we already know, suppose we have to create 1 ampere current, then the numerator, that is charge, should be 1 coulomb. Okay, and the denominator should also be 1 second. So we can say the current in a circuit is said to be 1 ampere if 1 coulomb of charge has been transferred in 1 second. Okay, the current is said to be 1 ampere when 1 coulomb of charge has been transferred in 1 second. So this is how we define electric current and 1 ampere. Now students, we are going to study about one more fact, and that is Ohm's law. Ohm's law we are going to understand by the same example we can understand. Now students, we have applied the potential difference. As you can see, now instead of random motion of electrons, the electrons are moving in a particular direction. So as soon as, suppose this is a variable band, okay, you can increase or decrease the potential. So variable potential difference is denoted by this symbol. Now if you will increase the potential difference, okay, how we can make the variable band? So I can tell you this. This we can do by applying our rheostat. Okay, rheostat is known as variable resistor, and this is the symbol for this. For example, suppose you want to increase the rheostat value, resistor value, then you will just shift this arrow and here, and you will study for this in your physics lab. You will even observe it. Maybe few of you have observed it. So this we will study later. So by using rheostat, we can increase or decrease the potential difference. So if we once we increase the potential difference, what will be there? Now the electrons, those who will drift in the direction of the opposite direction of electric field will increase. Suppose this electron wasn't affected by this, now this electron will be affected by this. This electron also will be affected by this. This electron will be also affected by this. Now, once I increase this potential difference further, what will be the condition? Then more number of electrons will start drifting in the opposite direction. What will be the result of this? If the number of electrons, those who will drift in the opposite direction of field, will create a condition that current will increase. Because once, what is electric current? We have studied I is equal to Q upon T. So if charge will increase, because electrons are carrying the charge. What is the charge carried by one electron? That is 1.6 into 10 power minus 19 coulomb. So once the number of charge will increase, because we can say I is equal to Q upon T, or we can say any upon T. Why I have written in place of Q any? Because we have studied quantization of charge. Then charge is in the form of packets of electrons. So I is equal to, in place of Q we have written any upon T. So if more and more number of electrons are increasing, because of we are increasing the potential difference. And once we increase the potential difference, electrons will increase, and because of this charge will increase, and because of this current will increase. So firstly, this condition was observed by Ohm. Okay, and he says if the physical conditions like temperature, pressure remains constant, then current flowing in a circuit is directly proportional to directly proportional to the potential difference. And this we can observe in this particular circuit as well. Okay, so I is proportional to V. Once you remove this proportionality sign, one constant will be introduced, and this will be introduced in denominator. So I is equal to V upon R. Okay. Now where R is a constant, and that is resistance. Okay. So how to define resistance? We can say, as this is in denominator, if resistance value will increase, the value of current will decrease. So we can say that resistance is an obstacle for electric current. So it will, greater the value of resistance will be, lesser the value of current. Or how to define it? This we can define, okay? Or we can say R is equal to V upon N. So resistance is the ratio of potential difference and current. Now students, what is the unit for resistance? The unit for resistance is ohm. Okay. So how to define ohm? 1 ohm. This is further asked in the exam. So unit for of resistance is ohm. Ohm. We can often use this symbol ohm. Now students, how to define resistance or how to define 1 ohm? 1 ohm. So we can see that R is equal to V upon I. So students, if we want to get 1 ohm, when we will get 1 ohm? When potential will be 1 volt and current will be 1 ampere. So students, by using this concept, we can define 1 ohm. The resistance in a circuit is said to be 1 ohm. The resistance in a circuit is said to be 1 ohm if 1 ampere of current flows by applying a potential difference. By applying a potential difference of 1 volt. So in place of V, we can write W upon Q upon I. Now students, the dimensional formula for W is ml squared T minus Q divided by Q. Q is equal to IT. So this will be 80 and divided by I. This will be A only. Now solve this and you will get ml squared and T will be plus 1 and become there minus 1. So T minus 3 and A minus 2. So this is the dimensional formula for resistance. I hope you understood this. Thank you. God bless.